So although there is going to be some bending behaviour in this St Pancras lighting, that if we look at the whole structure, there's going to be some slightly more complex things happening and how the forces are transferred. And we're going to use this model to show another way it can resist the vertical forces when in basically the ideal case, when everything's going as planned. When we look at the vertical loads on the lighting structure we're looking at, we need to take into account also the curved member underneath the main beam section. And it's working in, I guess you could understand it in a couple of ways. It's called a catenary arch, and basically when it's loaded, the beam, say by a uniformly distributed load, it goes into tension, just like the wire we've got in this little miniature model is doing. And the reason for this is that you could understand it maybe like a truss. So the lower members of the truss will go into tension, the upper members will go into compression, and the force will be transferred to the supports like that. You could also think about it like an inverted arch. So instead of the arch structure above going into compression and transferring thrust out to the supports, which then has to be resisted in tension by maybe a sort of bowstring like element, you can have the bottom arch, the inverted arch, going into tension and transferring inwards horizontal force, which has to be resisted by this beam-like structure going into compression. And we can see that by the makeup of the supports as well, because the fixed support there is at one end is oriented so that its major axis is bending in this direction, which is in part to resist that inward horizontal force. And although the other side is just pinned, quite often actually in St Pancras we see that this structure is duplicated. So we'll have a fixed support at one end and then double this structure up again and again, and so that the inwards horizontal force is going to be resisted by the equivalent horizontal force generated from the next structure over. And so they all work in harmony so long as the loads are equivalent. If not, then there's going to have to be some bending at the supports here.